Good day ka-CRT. Let's try this clock problem under algebra. What time between 7 and 8 p.m. will the hands of the clock be at right angle? So first, in our solution, let us get the initial position of the clock, which is at 7 o'clock. So this is the illustration. This is the longer hand of the clock. This is the minute hand. Then, if the initial position is at 7 o'clock, so this is the initial position of the hour hand. So, minute hand, the longer, hour hand, the shorter. So, the condition is the hands of the clock be at right angle. So, in this case, there are two possible scenarios wherein we can get right angle between minute hand and the hour hand. The first scenario is here. If this is the initial position, the 7 o'clock initial position, the minute hand will move somewhere here. And then the hour hand will move somewhere here. Let me redraw this. Okay, so this is the illustration that the minute hand and the hour hand is at right angle. So this is at right angle. Okay, so let us represent the movement of the minute hand from this position up to this position. So from this position up to this position, we will let the movement as x. In clock problem analysis, the movement of minute hand or the movement x of minute hand is equivalent to x over 12 for the hour hand. So therefore, from this position of the hour hand up to this, we can represent this as x over 12. To illustrate or to solve this problem or to generate an equation, we will look at the extremes or the boundaries of the hands. So from this side up to this side. So we will represent that using the given parameters here. Okay? So if we will use x first, x plus, to cover the boundary, x, and then from this position up to this position is the 90 degrees condition. So 90 degrees in terms of minutes, you should express that in minutes. That is 15 minutes. So this is the first representation to cover the boundaries of our drawing. You can equate this to another equation representing the boundaries. So for this side, let us use x over 12. X over 12. So x over 12 is from this position up to this position only. So to cover the boundaries, what is the value of from this position up to this position? And that is equivalent to the distance between 7 and 12. That is equivalent to, in terms of minutes, 35. Then with the solution, solve for x. this will give 21.82. So, therefore, with respect to this scenario, at 7 o'clock and 21.82 minutes, and in terms of PM, at this time, the minute hand and the hour hand is at right angle for the first time. We can also calculate other scenario, other condition wherein the minute hand and the hour hand is at right angle for the second time. So let us use this portion. Let us use this circle. So again, the initial position of the clock is at 7 o'clock. So to illustrate the condition wherein the minute hand and the hour hand is at right angle for the second time, let us illustrate this as the minute hand is in this side. So from 12 position, it will move up to this side. And the hour hand will move from this position, be up to this position. Okay? So they are now in 90 degrees or right angle. So let us illustrate or let us represent the movement of each hands of the clock or each hand of the clock. So from 12 position, 12 o'clock position up to this position, that is the movement of the minute hand, which is normally represented by X. The movement of our hand is from this position to this is X over 12. So in this case, in this drawing, our boundaries is simply represented by X. So we can just put X here and equate this to the internal opening. The internal openings are composed of this opening, the 12 to 7 position, which is equivalent in terms of minutes as 35. Okay? Then plus this opening, X over 12. And to cover the whole boundary, this opening, which is 90 degrees, and it is equivalent to 15 minutes. So solve for X here, it will give 54.55. Therefore, the time for this condition is 7 o'clock and 54.55 PM. So this is the time wherein the hands, the minute hand and the hour hand is at right angle for the second time. Okay? So this is our conventional method. Let me show you the shortcut method. This shortcut method, I call this a ham formula. So this ham formula is equivalent to 60H plus and minus 2A equals 11M. Okay? So this is the ham formula. Let us substitute. 60, H stands for hour hand, the initial position of the hour hand. And this is 7. Plus and minus 2A. A is the angle between minute hand and the hour hand. So A is right angle or 90 degrees. Equals 11M. Okay? So you just need to solve M using plus or and using minus. Okay? So using plus, m will give 54.55. And this is the solution for the second time wherein the minute hand and the hour hand form or at right angle. If you use negative here and then solve for m, it will give 21.82. So meaning you can still get the same answer. This is at 7.54 or 7 o'clock, 54.55 p.m. And then for this, 7 o'clock and 21.82 p.m. So this is my conventional method and my shortcut method in solving clock-related problem in algebra. Thank you for listening. Please like and subscribe to our YouTube channel.